Last up, we're going to take a look at some examples of three-point perspective. Now, this is the first time we all of a sudden have a vanishing point that's not on the horizon. The length and width of our objects are still going to be vanishing at a point on the horizon line, but our third vanishing point is going to be at a point either directly above us or directly below us. And you got to remember, it's in the direction you're looking. So if you're looking down, you know that third vanishing point is going to be in that direction. And if you're looking up, that third vanishing point is going to be up in that direction as well. So let's take a look at some examples and see what this looks like in real life here. So this is one of the best classic examples of three-point perspective. We're looking up at this building here, and we're looking almost straight up here, where we can see the sky, you can't see the ground, so you already have a good idea. You know that the horizon is where the sky meets the ground, and if we can only see the sky here, we know that that horizon has to be below us somewhere, because that's where we're standing, right? So we also know that the height of this building is receding away from us. Those vertical lines of the height are no longer perfectly vertical. You can see they are really pointing up towards the sky. They are converging upwards. So we know that our third vanishing point is going to be up at where the sides of this converge. So let's see if we can find where our horizon line and our vanishing points are here. So we know we can follow the length of this building. You can follow the edges of the building here. You could also follow those lines of any of the windows back towards the left here. And they're converging at a point that's way, way below us because we're looking so directly up. I mean, that horizon line is going to be pretty far away. So we're actually not seeing where they converge, at least in this picture here. And then the width of this building is extending down off to the right there at a vanishing point that's way below it down there. So we know our horizon line is somewhere beneath us. To actually find where that horizon line is, we would actually have to extend our paper even longer to be able to find it. But for now, this is good enough to know that it is down there somewhere. Okay, that third vanishing point, where is it? We are going to follow the height of our building now. So we're going to follow along the edges of the building upwards. Notice they are receding. They are converging. These lines are getting closer together, and if you extend them far enough, they meet at a spot right here. And it's actually inside our picture plane, and that's because we're looking so far straight up. There really is a correlation to how much your head is tilted and how close that vanishing point is. Because, you know, the sides of the building are literally pointing to that vanishing point. That's where they are converging to. So the higher you look up, the closer that vanishing point is actually going to be. To the point in like this example here where it actually is inside our picture plane. This is an example where we are looking downwards now at a building. So we're looking down at everything. We know that everything is converging and it's getting smaller as it goes away from us. So it's going downwards. We can follow the length of these streets and these buildings. They are converging off to a point over there to the left. And then the width of the street and buildings are all converging at a point over here to the right. And we know, horizon is where the ground meets the sky, and we can actually see the ground. If you look at the very top of the picture here, we can see the water. We know if you were to tilt this camera up just a little bit more, you would just see where that sky is hitting the ground. And that is right where our vanishing points are. That is where our horizon is. We're so close to just being able to see that horizon in our picture plane. And then to find the height of our buildings here, to find where that vanishing point is, we're going to follow where these lines are converging down to. And that's right here. So this time it's outside the picture plane. Our head's not tilted down quite as far much, and you can tell that because the horizon line is closer. And do notice that the horizon line and that third vanishing points are always opposite of each other. So if the horizon line is above, then that third vanishing point is going to be below. And it's directly below that building. It's not going to be off to the side unless your camera is tilted in any way. In this example, our head is tilted only up just a little bit. It's not as much of a forced three-point perspective. It's just like a little tiny bit of a three-point perspective. We can follow the length of these buildings off to the left here, find our vanishing point, follow the width to find our vanishing point here, and this means our horizon line is here. It's actually inside the picture plane, and that's because our head is tilted only just a little bit. And now if you look at the height of the buildings, those vertical lines aren't vertical and they're just a little bit tilted, but they are still converging towards the center up here. So this is an example now where our horizon line is in the page, but that third vanishing point is very, very far away. So when your head is only tilted a little bit, you're probably not going to be able to see that third vanishing point. But we could keep following those lines far enough and eventually find where that third vanishing point is. Here's an example of us in a church, and we are looking straight ahead in this building. So this is an example of what we could call a one-point perspective scene where we're looking up. So there's only one vanishing point here for the length. There is no vanishing point for our width because we're looking straight ahead at the back of the church here. So we've got one vanishing point here. We know that's where our horizon line is. This is a very similar example to the last one where we're only looking up just a little bit. So our horizon line is in the page. And then we are looking up. You can see the height of those columns. They're all kind of tilted inwards because they're receding up. So that means our third vanishing point is up here outside the picture plane. So you see it's a very similar picture. The only difference really between the two here is that we are looking straight towards the back of this church like it's a one-point perspective. We're not looking at a corner. So in this example, there are only 2 points, 2 vanishing points, but once again, it's still considered 3-point perspective because we're looking upwards. That basically trumps everything. As soon as you're looking up or down, it's automatically 3-point perspective, regardless of whether or not you're looking at the object or the room straight on or at the corner. So this is a similar idea, but now we are looking downwards and we are looking straight ahead towards that wall. So this is another example where we are kind of in 1-point perspective here. So we can follow the length of our room straight back to where our horizon line is. Remember, we're looking down. The horizon's where the ground meets the sky. We're looking at the ground. So we know that horizon line has to be above us at that point where those vanishing point meets. And then the height of this room, we can look at the height of the cabinet, the height of the doors. They're all receding downwards to the point where they converge below us, which is off the page again, because we are looking down pretty severely, but not enough that we're looking quite straight down yet. So we can almost see that third vanishing point, but not quite. And once again, even though there are only 2 vanishing points in this picture, it's considered 3-point perspective because we're looking down. And this is one of the trickiest examples. Stairs always tend to trip people up when they're starting off in perspective, and it's because of the banister. You know, you look at that banister, that stairs, and like the side edges of that stairs, those are all parallel receding lines, right? So people tend to follow those lines thinking it's going to lead them to the horizon line. But you have to remember, the horizon line is level to the ground, so you can only follow lines that are parallel, receding, and level if you want to find the horizon line, because lines that are not level will converge at a point that is above or below the horizon line. So you have to ignore any lines that are not level to the ground. And one of the things I really love about stairs is stairs are actually a really easy way to find where the horizon is, because remember when I talked about if you can see the top of objects, you know that the horizon line is above it. And that's what I love about these stairs is anytime you can see those top of the steps, like you start at the bottom, you can see the top of that step, you can see the top of the next step and the next step, but it keeps getting smaller and smaller until eventually on one of those stairs, about 2/3 of the way up, we can't see the top of the step anymore. And that's at the point where the horizon's going to be. It's going to be at that point where we can no longer see the top of the step because once it gets above the horizon line, we're looking up at it. So it's one of those things, if you forget about level lines, do remember that. Remember those other clues that we can use to look for the horizon line. So to find our vanishing point, to find our horizon line, we are going to be looking for lines that are level to the ground. So the steps, the very sides of the steps, it can be hard to see sometimes when using steps because they are sometimes just a very slight angle. But we can follow them all to find that vanishing point and look at it. It's meeting at that point on that step where we can no longer see the top of the step anymore. It looks like just a flat line. And it's exactly where I thought it would be. And this picture is also Not totally 1-point perspective. You know, we are looking at it at a slight angle. If you look at the steps themselves, they are angled a bit. It's because whoever took this picture, they were turned slightly to the steps. So there is a second vanishing point in this, but because we have one vanishing point that's really close, the second vanishing point is going to be super far away. That's going to be off to the side over here. So we could find that if we kept following it far enough, but we know we got that first vanishing point, so that means the horizon line is here. And also notice that I did make my horizon line crooked, and that's because the camera is crooked. If your camera is tilted or your head is tilted, that is the only time your horizon line is not going to be perfectly horizontal. Because, I mean, the horizon is where the ground meets the sky, so that's always, you know, perfectly horizontal. That's why we use that word, horizon, horizontal. But if we tilt the camera, we can adjust it. Essentially, you're adjusting the picture plane, so the picture plane is tilted. So that's why I have it at an angle just to match that there. And then let's find the third vanishing point. Now this is a tougher example because we're only slightly looking down in this picture. This is one of those examples. You can see the horizon line, it's not in the center. If we were looking straight ahead, the horizon line would be in the center, but it is towards the top end. So that means we do have our head tilted down even just a little bit here. So that does make this 3-point perspective. And you can tell by looking at the sides of each of those steps. They're not perfectly vertical. They're all angled down towards the center just a bit here. So if we follow them, and you can follow the side of that wall, you can see they're all just very slightly converging together as they go downwards. So that third vanishing point is down here. When looking for examples of 3-point perspective, I would go for something a little bit more obvious than this. I wouldn't just tilt your camera just a little bit. I like to see examples of 3-point perspective where they're tilted a lot more. So whenever you're looking for examples of 3-point perspective, I would look for something just a little bit more dramatic than this. So I would really tilt that camera up or down. Okay, and that's it. So here's some examples of 3-point perspective. Wanted to give you just a little bit of a chance to see what it looks like in real life, both interior and exterior. Remember, 3-point perspective only happens when you are looking up or down in any way.